What is there an additional class after this we have to have? Is it small business management or policy?
This one?
Yeah.
Well, that might be operations.
Yeah, I think that's operations. Yeah, never mind. Wrong class.
So this would be the end of that. Yeah, this one's being changed.
This is cherry on top.
Looks like we have more people today. Alright, so today I think we probably could finish this chapter here. Okay. Alright, so let's review what we learned in the last class. So in the last class, we talked about how do the producer make a decision on the optimal output Q star. Okay. And first I introduced you a function. What is that function? I introduced the function. What's that function? Cost function, right? Okay. We utilize the cost function to derive the formula and for the optimal output. Okay, so we start with the cost function. Okay, we say this is the total cost. It is a function of the output. Now from the total cost, and we derive the average total cost and the marginal cost, right? Okay, and I show you what do they look like. What do they look like? Average cost, yes, that's this shape here. Okay, and then after that, I show you the relationship between all those marginal cost and average cost. It looks like this.
Yep.
So that's what we learned. And so this is a graph. Then when we derive the optimal output, okay, we utilize some concept from the cost function, okay, to derive the optimal output. And the principle we use to derive the optimal output we call the marginal principle, right? Marginal analysis. You guys with me?
And for the marginal, we use the function.
Yes. So what is that mathematical formula I introduced you last class to derive Q star? Price equal to marginal cost, right? Okay. Because the price is your marginal benefit of selling one more unit. Marginal cost is your marginal cost of selling one more unit, right? So the marginal cost must equal to the marginal benefit. So, okay, so that's what we learned. P equal to MC. And we use this P equal to MC, this condition here, to find the Q star, right? Okay, so after we learn this, and we utilize this on the graph as well, right? Okay, so we say if the price is right here, then you know the optimal output should be here.
Right.
And we're able to find the total revenue, total cost, right? And we're able to find the profit on the graph. Okay.
And the total revenue would be that whole rectangle.
Yeah, will be here, right?
Right.
Okay, and total cost, you need to find average total cost by using this Q star, right?
Mm-hmm.
And we can find that. Okay, remember that stuff?
Yep.
Okay, good. And then the end of last class, I talk about the operating profit, economic profit, and the break-even point and shutdown point. Okay, so what is operating profit?
AV at the bottom part for the ABC.
It is, what's the definition?
Oh well, I mean, I was gonna say short term.
It's a profit you consider in the short term, right?
Yeah.
And how do we get operating profit? What's the formula for that?
You take out the fixed cost.
Huh?
You take out the fixed cost.
You take out variable.
Right.
Or variable.
You take out the variable
Yeah, that's-
cost, right, from the total revenue. So operating profit profit is equal to total revenue minus total variable cost.
Right.
And then we talk about the economic profit equal to what?
Total revenue minus the total cost.
Total revenue minus total cost. Okay? So why do we want to differentiate these two profits?
Short term, long term.
We're going to use this to determine whether you want to run in the short run. We're going to use this to determine whether you want to run in the long run, right? Okay?
Wait, is it total cost or total fixed cost? Is this total cost?
This is total cost.
Okay.
Not the fixed cost does not show up in the profit.
Okay.
Well, the total fixed cost is part of total cost.
Okay.
It includes that, right? Okay. And then we talk about, okay, if the price is right here, is right here in the middle, then in this situation, the firm will
Run in the short term, but not in the long term.
run in the short run, but not in the long run, right? How about the prices up here?
But
How about the prices is down here?
neither.
Neither, right? Okay. So how do we determine, the cutoff point? Then we say, okay, there's two cutoff points that is very crucial. And this two cutoff point is this. Is one of here, this price level, and this price level. What do you call this price level?
Economic.
Break even point. Break even point. Because at that price level, you are at the bottom point of ATC, so your economic profit is equal to 0.
Oh, okay.
Okay? And how about this price level? What do we call this one?
Shut down.
Shutdown point. Because any price below that, you're going to shut down. At that point, your operating profit equal to 0. Okay? Right? At the very end of last class, and we talk about where the supply curve is derived from, right? Where the supply curve is derived from?
It's from the marginal cost.
From the marginal cost. And it's which part of marginal cost is the supply?
It's just a straight part.
Upward and then
Get rid of the
right
curve.
From here,
Yes.
above. Okay, great. Okay, so that summarizes what we learned in last class. So we already know how do we determine the optimal output now. We use this condition. That's how do we depend on using a graph to calculate, and to determine the output. So we have to finish the second decision. Okay, so what's the third decision we're gonna talk about? The scale, right? Okay, so because that will be the very first decision you have to decide, and we'll talk about the last, right?
Well, scale is the last, right? Scale is the last, right?
The last one we're gonna talk about, actually, it is the first decision you're gonna make.
Okay.
Before you determine how much to produce and how many input to use, you have to determine what the size of these things, right? So that's very first decision, but we're using the backward induction method, so we're gonna talk about this first decision last. Okay,
Yeah.
so remember, that's what we talked about. We have 3 decisions, but we use backward induction to talk. The scale. Okay. All right. So talk about the scale. We have to introduce you the time period of long run. Okay. So before, when we talk about the decision on the input, output, and we're assuming that we are in the short run. So all these 2 decision makings we've been talking about, we are under the assumption that we're in the short run. Okay, because in the short run, and this is fixed. Okay, we have to fix this in order to determine the output and input. Okay, and in the short run, this is fixed. Okay, so now we relax the short run of assumption. We assume we're in the long run. Okay, so in the long run, you can change anything. In the long run, allows you to expand or shrink your business, and will allow the competitors to come into the market. Okay. I'm going to introduce you here is an average cost curve. But we have talked about the average cost curve, right? But the average cost curve we talked about the last class. It's a short-run average cost curve. So it's an average cost curve for a fixed scale. So now I'm going to introduce you a average cost curve. That is what we call it, long-run average cost curve. Cost curve has the same shape as short-run average cost curve, but it has totally different meaning. Okay, for the short-run average cost curve, you give an output level to tell you what is the average cost for that output, right? Okay, but for the long run, no. Okay. For the long run, this is still the output level. This is still the dollar, but now each point along the long-run average cost curve represent a different scale of the business. Let's say this is scale 1. This is scale 2. This is scale 3. This is scale 4. So each different point represent a different scale of the business. As you move toward the right direction, what happened to the scale? As you move toward direction, what happened to the scale?
Gets bigger.
Gets bigger. So the scale 2 is bigger than scale 1, scale 3 is bigger than scale 2, and scale 4 is bigger than scale 3. So that's how we define the long-run average cost curve. It's a curve that represent a different scales. But we're not finished yet. The long-run average cost curve's purpose is not finished yet. Okay. Let's suppose this firm determined a scale on the scale. They determined they're going to use scale 1. Okay. Once the scale is determined, remember this is the very first decision the firm has to make, right? Once this decision is made, and the rest of the decision is just the output and input, right? So then the decision changes from long-run decision into a short-run decision. Okay? All right. So once the scale is determined, then the decision for the firms become a short-run decision. Okay. Okay. So let's suppose the firm is right here.
So when you say within a scale, you mean
the firm decide, I'm going to build a restaurant, Shogun, this big.
Right.
They determine the scale. Yeah. Once they determine the scale, then their decision will be the output, the input. That will be we consider short decision. So scale is right here now. Now the next decision determine the output. To determine the output, we learned it from last class, right? We just reviewed it. You have to have what? Short-run average cost curve, marginal cost curve, and market price to determine, right? Okay. So how do we find those? Okay. That's what the long-run average cost curve is going to help us to do. Once you determine the scale, and then the short-run average cost curve for that particular scale, and it's going to be tangent. It's going to be tangent to the long-run average cost curve scale at that point. So I call this short-run average cost curve for scale 1. If you determine the scale, which is scale 2, then for this particular scale, the short-run average cost curve would be tangent to this point back here. If you determine it's a scale 4, then the short-run average cost curve for scale 4 it's going to be here. Okay, so that's what the long-run average cost curve is designed for. It's designed for us to locate the short-run average cost curve for each different scale. Okay, now let's look at this. When you move from scale 1 to scale 3, what happened to the short-run average cost curve?
Down.
Goes down. A little bow and down. Is it good news for the firm or bad news for the firm? Good news, because it is the average cost function, right? When the average cost function goes down, it is good news for the firm. So it saves money for the firm. So what this tells you is, from here to here, if you increase the scale of the business, you're going to experience a lower average cost of production.
So you reach that threshold of scale 3, and then you
Until you reach that, then if you keep increasing the scale, then your average cost function is going to go up.
I
Which
imagine
makes you lose money.
wouldn't it potentially come back down at a certain point?
Okay, so that's what I'm going to talk about. So
Business, right?
the ideal scale for the firm is what? It's this, right?
So in a real
Will
life,
be, go ahead.
in a real life situation, to apply this, it would be like a decision, square footage,
Square footage,
for a warehouse or a,
that's right. The capacity of the production, that will be considered the scale. Yeah, okay. And then in the real world, if the firm or the business owner knows where the scale 3 is located, and it would not be a problem, right? They will jump into scale 3 right away because that will be the lowest average cost. But in the real world, the business owner, they do not know where the scale 3. So what you're seeing here is sometimes the firm will merge. Why they merge? I mean, the intentional merge is they think they're going to lower the cost. Okay, but then sometimes they make the firm or company too big. They reach the point here. Then they start seeing the rising average cost, right? So they start cutting branches from the other area, from the other countries to decrease the cost. So in the real world, that's what you see. You see the firm is back and forth. They will increase scale, they will merge, they will acquire other company. Then at a certain point, they will realize it's too big to manage. They're going to cut branches. So in the real world, you're seeing this. Okay, but eventually, given the longer period of time, they would be able to figure out roughly, approximately, where the scale 3 is located, and that's where it's going to want to be. So this is what we call the long-run average cost curve. Basically, what presents you is a relationship between a certain scale and average cost function. So this picture here is still the picture that describes the characteristic of the firm. This firm's cost function. So this is the graph to describe the characteristics. The nature of the production for the firm. So now I'm going to talk about this two stage. So in the first stage, while you increase the scale, you're seeing decreasing average cost function. We call this the economies of scale. So what the economy scale tells us is you're going to see the benefit of a larger scale. If you are right here, you should increase the size of your business.
And you'll see the change in what? You'll see the change in what?
See
the benefits of what?
Lower cost, more profits.
You're going to see the decreasing average cost.
Oh.
Okay, when you increase the scale, you're going to see the change of the average cost,
Okay,
and it's going to decrease.
thank you.
And this section here, this stage here, we call the these economies of scale.
This economies.
Which means you no longer benefit from a larger scale. If you increase your scale, and your average cost function is going to go down. All right. Okay. So now let's continue with our discussion. Okay. Let's suppose the firm is choosing the scale 1. Okay. And once this determined, the firm decision in the short run, right? Determine output. So we know this is a short run average total cost curve. And also we know this is marginal cost curve. Okay. What else do you need to have in order to determine this firm's optimal output? The price? Market price of the good, right? Market price. So, just this graph that describes the firm's characteristic is not enough. We need to know what's going on in the market to see what the market price is. So next to it, I'm going to draw the market for this good. And we're assuming we're in a perfect competitive market. If we're in a perfect competitive market, then the price is determined by the demand and supply. So this is the price the firm can sell the good at. What we're going to do is we draw this graph next to that so we can extend this price right here. Can you tell me at this market price, if the firm is at scale 1, is this firm making a positive economic profit?
Yes.
Yes. It is about the lowest point of short-run average total cost, right? So it's making positive economic profit. And the firm is going to produce Q1 stock to produce this much, right? But do you think the firm will be content with the economic profit made?
Probably not.
No. Because you're
What the firm is going to do now?
increase their scale.
Increase the scale. Okay, because if they increase the scale, what happens is the average cost curve is going to go down. And if the price is still right here, you're going to have a higher profit margin.
So in theory, you just keep going until you see your average cost
That's right.
go
You're
up.
going to that's right. In theory, you're just going to keep going. Okay. So for the firm, they are not going to be content with whatever the profit they made here. They're going to keep expanding. Okay. All right. If the firm keep expanding, the scale is keep increasing, what's going to happen to this output?
It's gonna go up.
It's going to go up?
Mhm.
Okay, so this is going to go up. Now the output is for the scale 2 is. So when this goes up, the change in the firm's action is going to have some influence on the market. Right? What kind of influence that's going to have on the market? The firm is now expanding, is bigger, they're going to produce more, they're going to produce more, sell more in the market. How that's going to affect the market equilibrium?
It will be less in
The
demand.
price will be lower. Yeah, it's gonna affect the price, right?
Yes, but how the price is going to be affected?
Negatively.
The price is going to go down. Why the price is going to go down?
Because people produce more
Demand or supply is going to be affected.
Supply will move down
The supply is going to be higher or lower?
higher.
Supply is going to higher, so you're going to see a lower equilibrium price, right? And now, this affected this.
Yeah.
But is this change going to come back affect this as well?
Yes.
How?
Your margins are a little bit lower, but you're still enjoying more than you are.
The price is now lower, so the profit you made is going to be smaller than before, right? But as long as you still have the profit, the positive profit margin, you're going to keep expanding. So you see in here, this is a dynamic movement. So this is keep the firm here is going to keep producing more. As they keep producing more, and the price is going to keep going down. But as long as still there is a positive profit margin, you see this movement will continue.
I have a question.
Sure.
So would it be possible to make like a larger profit at scale 2 than 3?
Not possible because this has a lower cost.
Unless
The cost of making the goods at this scale is going to be smaller than this.
that price differentiation was less between scale 2 to price 2.
Yes, so if you consider that, yes, before you're at scale 2 and there's a price level, right?
Right.
You're making like, let's just say $100. And it could be that you're at scale 3 and the price moves, you only make $50. So it is possible.
Okay, that's what I was asking because.
Yes.
Okay.
Yes, that's possible. That's a good question. So, but as long as there's still positive profit margin, they will.
So why would we keep expanding until we get to scale 3 if we have a larger profit at scale 2?
So only because the larger profit here is because the price was at a higher level. Now the price has gone down. The price is not going to go up. It will keep going down.
Wait, but we still have a larger profit.
That's what I'm saying. The larger profit that in that situation I talked to you, that for scale 2 than scale 3 is because the price was at a higher price.
So in that scenario, you'd recommend staying at 2.
So it's not what we said. Will we just keep?
Okay.
So regardless of the profit, we should go to scale 3 because the cost is lower.
Because if the price is maintained at this level,
Right. Okay. Given that the price. stays
yeah,
the
if
same.
the price is maintained at this level, it is.
Oh right, yeah, okay.
You're
I
going
get
to.
it.
That's
No,
right.
I understand that, but if we keep moving down, the price gets lower, right?
Gets lower. Yeah.
So then it makes our profit lower. But if the price stayed the same, I get why we would stay at scale 2.
It makes the profit lower for one, but you're selling a lot more, so therefore your overall profit goes up.
No, it's not.
I think that.
I'm sorry. Okay, it's
I think
no.
that if
Well, like you know what I mean?
it's
You're-
not because of you.
if your actual LRAC were a little bit steeper, I think that it would depict a little bit clearer of a picture. Because as right now, scale 2 looks as if it will have a higher margin with the price than.
It should be higher than this. Yes. So
that in reality, that would be a much bigger differentiation between scale 3 and scale 2.
that's right. Yeah. But I know for a question you still have not feel that question is answered. Okay. All right. So let me think a way to but I understand what's your
Okay.
point here. You're saying okay why we don't not just stay here because later on I'm going to let me move to the next point and you will
Okay.
see what I mean here. Because if this remain the same, okay, let me bring the other point. Okay, I'll make it better. Okay, so that's what's happening to the firm that already exists in the market. Okay, remember in the long run, one of the assumptions that we assume is we allow entering and exit of the firms. Okay, so if we allow the entering of the firms, and when the firm from outside this industry, outside this market, seeing the firm exist in the market and making a positive profit margin, it's like when Apple company start selling MP3 iPod for the first time, they make a lot of the profit margin at the beginning is really high, right? I think the iPod was selling at like $400-500 at the beginning, and when there was no competitors. But then since they made a lot of money, other company later on start jumping in, making MP3 players, similar products. So eventually iPod price drops, right? Okay, so that's what's gonna happen. If outside firms see the profit opportunity within the market, they're not gonna stay outside. They're gonna come in, share the profit with you. Okay, so when they come in, they're going to produce either close substitutes or something very similar to the product, right? Okay, so what I want to ask you here is, if that's happening, how this going to be affected? How this going to be affected when the outside firms start coming in producing?
The supply will increase.
The supply will keep going up, right? So the price will keep going down. Okay, so firms will come in and produce, and this will push the supply even further. Price will goes down even further. So even you do not move from scale 2, the price will keep going down. No matter what you're going to do, the market price of this good is going to go down, and your profit is going to go down, no matter you're going to make action on your scale or not, because the overall supply in the market is bigger and bigger. So how do you make the more profit while the price going down? You're going to choose a lower cost function.
Okay.
Yes.
Got it.
That makes sense.
So both will happen the same time, but as long as there's still profit margin in this market, okay, eventually the profit margin for the iPod exhausted. There was no profit opportunity anymore. That's why Apple company has to ship to some other, ship to iPhone, some, iTouch, and eventually whatever, iWatch, maybe iLight. Everything will be I, right? Somebody, actually my friend make fun of me, someday we're gonna have I. I.
Oh gosh.
Alright, okay, so as long as there is a profit margin, and we're going to keep saying this, and this will keep changing, and this will keep changing, so everything moves simultaneously. And this is a dynamic movement we're talking about. So there's no chicken and egg. Which one starts? No, we do not know. They're constantly, influencing each other. There's no end. Okay, but there is a convergence. There's convergence. What is convergence? The price eventually is going to be pushed down to a point where this movement temporarily stops.
And then it stabilizes, I guess.
Temporarily. So where is that price level that will make this movement temporarily stop?
When we scale through.
When the price is right here.
Then what happens?
So that's the lowest.
When the price is right here, the firm reaches scale 3, the firm makes 0 economic profit. So they will not expand anymore, because by expanding, this means they're going to have a loss, right?
Mm-hmm.
And outside firm will not coming in because there's no profit margin left. So when the price is pushed at this point, pushed to the point at here, and then when the firm chose the scale 3, we're going to have what we call the temporary stable situation. Temporary stable situation.
And then other people leave and the price goes back up.
Then something happens, and there's like a cycle. This dynamic movement is moving again, but it's always moving, but there is a convergence. You see, that's the thing. Convergence is always, market always push everything to reach this point. This point we call it. This is most efficient point, because all the profit margin is being exhausted in the market by the competition, and consumer actually benefits the most at that point, because there's no profit left. So to produce a surplus turns to zero. All the surplus goes to the consumer.
Okay.
Yeah. So this is the point, actually, you and I as consumer has the most surplus, because all the profit has been exhausted by the competition.
So if that price point were to drop beneath the point that you've
It will
indicated,
not drop further.
Okay.
Because, there will be no more higher supply. So the price will stay
Okay.
as right here.
Mm.
Yeah. So that's why we call this is the long run equilibrium point. P is equal to short run average cost curve, short run marginal cost curve, long run average cost curve, and long run marginal cost curve. So at this point here, if everything here is the same, then we reach what we call the long run equilibrium point. So again, this is what we call the temporary stable situation. Even if equilibrium point means stable, it's temporary because you know how many things that's going to affect the supply and the demand, right? Like hurricane comes, or our income has changed. Anything that happens is going to affect the demand of supply, and this will move again, and this will make change again. So any external factor change will make this dynamic start moving again. You can think of like this very sophisticated machine, but there is an underlying mechanism behind it. Yeah. Okay, so this is the market for this good, and this graph here represents the characteristic for this firm. There's something.
Now working this problem out, we don't have to have that scale like exactly right. We just put the price or whatever. I'm talking about like that graph you have to the left.
You would just assume that the supply
We would
is
just
going up.
we don't have to draw it. We just assume, right?
If I want you to draw, then you have to draw.
Oh.
Right, that's the
Very good
question.
answer.
If I want you to draw, you have to draw.
Let me jot that down.
Okay, so in this picture here, we have the firm's characteristic. We have the market for this good. There is something else. It's very important we have now included in this dynamic moment.
Supplements, products, supplement.
So when this happens, the existing firm will, Apple company keep producing more and more iPod. And outside firms start coming in, making a lot of different kind of MP3 players. When that happens, that's going to affect this MP3 player market. But what other market this will also going to affect?
Complementary earphones? Complementary products? Yeah, like headphones, stuff like that?
Yes, that will affect that. But what else?
Customer.
Customers. We're talking about the consumer demand. Demand may be affected. Yes.
Yeah, demand for either one of the products.
So in addition to this MP3 player market, somebody said the complementary goods market will be affected. What else? That eventually the change of this market here gonna come back influence this.
Maybe the
I know there will be a lot, but we're gonna want to analyze the most crucial one.
Maybe the storage mechanism or whatever it is that's in the MP player, maybe that the natural resource price goes up and affect that.
So what he's talking about is what?
Chip.
The market for what?
Raw materials.
The market for input.
Input.
So this is what we call the output market, right? The market for MP3 play. But when you produce a lot of this product, you need more input. You need more people, you need more raw materials, right? That market is also directly affected. Input market. So this could be labor market, the person who computer engineers, okay, and who design the iPod, The workers will work on those, or could be the plastic in kind of just cheap, those kind of materials used in iPod player. Okay, so when this happens, which one is going to be directly affected? Demand or supply?
Supply.
Demand.
Demand.
You need to produce more, so you will require more inputs. So you demand more inputs. So now more and more company want to hire the people with this kind of expertise. So the demand for that kind of labor increases. Demand for the chip increases. Demand for the plastic increases. So this will goes to that way, right? When that goes up, what happened to this?
Price goes up.
What is this price?
Price of labor, chips,
This right
resources,
input
whatever.
price. When the input price goes up, it is good news or bad news for the firm?
Bad news.
Bad news. So how this, it's going to affect this now, right? So how this is going to affect here?
Your
Because that's going to go into the cost function now, right?
your cost curve will go higher.
Which one?
The entire LRAC.
Exactly. The entire, this big bowl going to be moved up.
Someone's getting in there.
It's going to shift up altogether. When they shift that altogether, every short run, every cost curve is going to shift it up. So make your profit margin smaller.
So then at that point, it wouldn't be advantageous at all to stay in that market, given that price point right there that you still got, if that were to happen. Because then you're just losing money on day-to-day operations.
Well, you will never, if the price is still here, you still have the profit margin, yeah, but it's just smaller, okay? While this happening at the same time, and the profit margin is just shrink at a faster speed. But again, as long as there's a profit margin, and this will still continue, and they eventually converge to this point. Okay, so here we only pick two markets, but that's not the only two markets going to affect this, but I picked this because they are the representatives. Okay, the whole market is like this, very sophisticated machines. They are interconnected, everything happens, they're going to affect everything else. So it is in a constantly in a dynamic movement. But there is a convergence. That's what we're learning. The convergence is here to bridge this long run equilibrium.
So really all this is just helping you mitigate against potential costs. Because it is what it is.
Yeah, exactly. It is what it is, yes. So basically what it tells you is markets, if the market is completely open, okay, there's no barrier to enter or exit. We have completely open market. It takes not very long time for the profit opportunity to go away. It takes no time if we have completely open market.
If you come back.
Yes, because we allow the competition eventually come.
In the output market, the price is going down, and in the input market, the price is going up. Which one is the
This is the price of the iPod. $400, right? Before $400. Then next year it costs $350. The price of the product itself. This is the price of the input. The wage, the price of chip, the price of plastic. Yeah. The input price goes up, the output price goes down, and both will make the profit go down. So this is ideal, not ideal, in a perfect competitive market, and this movement will run very fast, and eventually it should be in a couple years you should not see any profit.
So are there people out there working for Fortune 500 companies that can come up with representative charts like this and show how volatile a market is? On real time basis.
Yes, when they do a presentation, that's what they're going to do. They're going to bring out, okay, this market have influence on our profit, and how this market are changing, how those, the changes in those market affect our profit. That's our strategy to counteract those changes.
Okay.
Yeah. So that's why understanding this stuff is important. Yeah. Mm-hmm. As long as you understand this whole picture, you can apply it later. Yeah. So any question here?
So the second one,
Mhm.
it makes the whole curve shift up.
Yeah, because now the cost of making the goods is higher overall.
Right.
So the higher overall cost, all the cost function going to be shift up. Yeah.
All right.
Mm-hmm.
Awesome.
Yeah. But do you think there's any chance this can go down?
I'm sure.
Absolutely.
What?
New
What-
technology.
Technology,
Or maybe,
right? Yeah. So that can go down as well.
Cheaper taxes.
Mm-hmm.
Or maybe we find a new natural resource.
Yeah.
Yeah.
The new natural resources will make the resources cheaper. So it's all can happen. Yeah.
So if P, what are those two letters? PX.
This one.
Yeah. So if that goes down, then the whole shit goes down.
This goes up. But if this goes down, yeah.
Then the whole graph
Then will go
okay.
down. That's right.
All that is just any cost
Yeah.
associated with it.
Mm-hmm. Mm-hmm. That's right.
Awesome. Okay.
So this just give you a kind of picture in your head.
Yeah.
Yeah, what it's like in the market, how it moves. It would be great if you can stand here talk to us about this. Practice it and how to practice this, okay? Oh, wait. Still plenty of time.
Are you taking questions about homework?
Not yet. You have a question?
I had the same questions.
Already, you guys ready?
Yeah.
Because there's a question related to this.
Well, I mean, there's one that there's a section in the table that we're supposed to do. It's like
I know you talk about average cost and.
it's like VMPX or
Yeah,
something
yeah, I
like
know
that.
that one.
So I
This
have no
one.
idea how to do it.
Question 2. Let's talk about the last 10 minutes, okay?
Okay.
It's not related to this one. Okay. Is it your question?
Same questions.
The chart? This
Yeah.
chart. Okay. That chart is hard.
Yeah. Well, I mean that last section of it, as far as
Okay. All right. We're gonna talk about that. Okay. Okay. All right. So the last couple of things.
Oh yeah.
Okay. So last couple of things we want to talk about is related to the multiple output. Okay. So far we're just assuming that this manufacturer produce only one thing within the business, within the company. But sometimes they produce more than one thing, and that is actually in most of the cases, right? Okay, they produce camera and MP3 player and something else, right? So the last section we're going to talk about, and when is the situation you want to produce more than one product than just single product? Okay, so that's what we're going to talk about. Multi-product functions. Okay. The first thing, if you can achieve economy of scale by producing more than one product, then it's better, it's a good idea for you to do it. What is the formulation for the economy of scale when you produce more than one product? It's like this. Suppose you produce 2 products, good 1 and good 2. Okay, so use Q1 to represent output on good 1, then use Q2 to represent output on Q2. Okay, so if the function, the total cost of function when you produce this both products together is greater than this. It's greater than the sum of the cost when you produce these two goods separately. Then we call you how economy of scale by making both.
What do you mean?
Wait,
So,
so making, so it's,
Let me go through example, then
yeah.
you will
Okay,
understand.
so-
Okay,
alright.
let me go through example. Okay, so suppose we have total cost function like this. 20 plus 3Q1 plus 5Q2. Cost function, right? Okay. So if you produce two goods simultaneously, just within the same manufacturer, and that's the total cost. But if you do not produce both goods together, you produce them separately, you just produce Q2, then this will be 0, and the cost will be this, right? Okay. Or if you only produce Q1, you don't produce Q2, will be 20 plus 3Q1. This will be 0, right?
So you,
Okay. So you add these two. So if you produce these two goods separately, then the total cost will be 40 plus 3Q1 plus 5Q2, right? And it's higher than that.
right, so it'd be
Okay.
better to produce them both
Together.
at once.
Okay, so what this tells you is by producing them together, you save on the fixed cost. The iPod probably use the same kind of fixed cost as the iPhone.
so basically, all you're doing is paying for one light bill instead of two.
That's right. You're making to using the existing equipment and using the existing and the plants, everything. Yeah. So that's what we call economy of scale. Okay, by producing more than one. So this is how do you check? If I give you a production function like this, then you just plug 0 into one, then plug 0 into the other, add them up. If this is higher than that, then you say you have economy of scale by producing more.
Shouldn't it do that every time? I mean, what would be a situation in which it wouldn't?
I mean,
Well, what if, okay, if you, let's say iPod, what about clothes?
Okay.
iPod and clothes.
So
They don't share
associated products.
They don't share the common fixed inputs. So you probably have nobody going to, and make clothes and iPod at the same time, right? No company will do it. Yeah. Right? Let's assume.
The eye shirt.
Yeah.
I should.
okay, I'm gonna write that
It's
down.
some fun on the shirt. I love it. Go and take that and you just patent it.
Make a little money.
I like I. Just the sound of it.
I-E-Y-E.
Yeah.
Yeah.
I want to see somebody really do this in like a case study.
Ooh.
What case study?
Like he's just saying
Like
like,
I'd like to
got-
see like Nabisco or Johnson & Johnson
Mhm.
show me their stuff like this. You know?
Hmm. Ah yes, son, what is your trade secret?
Okay. Alright, so the next multi-product function I'm going to show you is called cost complementarities. Cost complementarities. This is T.
That's what you would call them, cost complementary.
Cost complementarities. Okay. So what this tells you is, okay, so actually the nature of economy scale is they share the same resources when they produce it, right? Then when you produce them together, you save on those fixed costs, the fixed input. Okay, that's the essence of this. This is different. Okay, even it's still the same money by producing two, but it's different. What they're saying here is the production of that one product is going to decrease the marginal cost of the producing the second product. That's what it means cost complement. So production one product is going to have influence on the marginal cost of producing the other one.
So like an example might be if you produced an iPhone, there may be some sort of like temperature that a certain machine has to reach, and it costs more money for it to get up to that temperature if you were to start it from scratch and make something else. But you already ran an iPhone through it, it's already reached that temperature.
Yeah, it could be. That's right. Because the technology, you already figured out that part. You can just use that technology to the other product. Use it on the other product. That's right. Yeah. So that decrease the cost of making the other product because that technology has been invented, and so our research and development cost is saved on that part. Yeah. All right. So how do we mathematically and to prove this kind of thing? Is this. Okay, remember we have two products, we just assume two. First, you derive the marginal cost for the one product. We learn how to do this, right? Okay? And then you take the derivative of this marginal cost for good one, take it another derivative with respect to a second good. See whether it's negative or not. If it's negative, then it has cost complementarities. I'll give you an example. Cost function is 100 minus 0.5 Q1 Q2 plus Q1 squared plus Q2 squared. Okay? Now we are taking the derivative with respect to Q1. And then it will be marginal cost for Q1. Okay? So we're taking the derivative this with respect to Q1. When we do that, we treat Q2 as what?
Constant number.
Constant number, right? Okay. What happened to 100?
Disappears.
Disappear. Okay, what about minus 0.5? Stays it. Okay, what about Q2? We treat it as a constant number.
Stays.
It stays here, Q2, right?
Yeah.
Okay. Alright, so how about this? What's the derivative? 2Q1, right?
Yep.
What about the derivative?
2Q1. Wait, is that what exponent?
It's a constant.
We treat it constant, so it will go away. Okay? So this is the marginal cost for good one. Okay? The formula says that you're going to take the derivative, the whole thing now, with respect to Q2. So now you take the derivative of this with respect to Q2. What's the number here?
That's a negative
0.5, right?
And
This one
no, it's
goes away.
Yeah.
Goes away. Because we treat this now as constant number.
Shouldn't that be 2Q instead of Q2 at 0.5? Aren't you getting a derivative?
No, this is a number in front of Q2, right? We're taking the derivative of this with respect to Q2, so that's the number we bring it down. Right?
So the first
And this one we treat as a constant number, so it just becomes 0. So it's negative right now. So there's a cost complementarities there. So the rule here is whenever you take the derivative with respect to one variable, you treat the other one like constant value. Chase, are you okay? You don't like derivative stuff, right?
Can you go over it one more time, please?
One more time, yeah, okay. So first we take the derivative of this with respect to Q1, okay? So this will go away, right? Minus 0.5, you copy down, okay? So we're taking the derivative with respect to Q1, so we treat this constant number like 0.5. So you just copy Q2 down here, right? So that will be the derivative of this term, okay? Next term this, the derivative of this would be 2, bring it down, Q1, the new power is 1. It's 2 minus 1. Are you following me here, Robert? Which part you're not? Which part?
Just gotta brush up.
I get it.
You got it?
Yeah, you bring it.
Then this one will go 0 because it takes that we treat this as constant number. Okay, so now we have this. Then we take the derivative of this with respect to Q2 now. So we treat this as a constant number. When we treat this as constant number, they just go away. So the derivative of this with respect to Q2 is minus 1.5 in front of it. You sure?
I have a question.
That's not the
I
same.
haven't taken calculus in a while. But
I really want to teach calculus, so you guys are doing. Okay, go ahead. I'm sorry.
so it's taking the derivative of the function, like of Q1. Why would it? Is Q2 still there because of the 0.5 in front of Q1? Like I don't get why taking the second derivative it just leaves, but then taking the first derivative it's still there. It's a constant.
Like pretend there's a 1 on top and then you're timesing the 0.5 by 1.
Okay, so you're talking about why this is still here. No.
No, she's
Why-
talking the
No.
0.5.
No,
Subtract
no.
You're talking about why this is here.
But why that one left? For
This one, which
No.
one left?
In the second equation, the Q1.
She's yeah.
right here, we treated this one as a constant.
That's right.
So we put it here.
That's right.
But then here, it's a constant, right?
Yes,
But it's 0.
that's right. Okay, look at this. 3x plus 5, both constant. When you take the derivative of y with respect to x, what happened? 3 here.
3 and 0. Okay.
You
So it's
see,
gotta be.
as it stands alone,
Got it. Right.
it goes away.
You're good at.
I forgot.
Right? So that's the form you look at y and x, right? Right?
Man.
It's not that hard actually. As once you know.
We're on two, but we're on two fast enough.
It just, if it's helpful for you, just change it into the number. Because then I think it's easier to see, right? But you have to change it back, okay? Change it back.
Alright.
Okay. Alright, so we still have 10 minutes. Perfect. I can talk about that question, the chart question.
Yeah, please. It's just the very last portion of it. It's like V MPX or something like that.
VMPK.
Yeah.
VMPK is equal to P multiply MPK. That's it.
Wait, say that again, sorry.
VMPK
Uh-huh.
is equal to price multiply MPK.
Oh my gosh. I was looking for some crazy crap.
Yeah, price already tell you is $4 per unit.
Right.
And MPK you already got that number.
Right.
Just multiply
Uh-huh.
this two.
Then you get V in
You got VMPK.
BMPK
Wow.
is equal to price times MPK.
But if they don't give you MPK, you would have to find
You have to find MPK.
Wait a minute.
Right,
Hold
and
on,
then you're
sorry.
taking a derivative or something.
Yes, MPK will be the derivative of the.
Capital.
But okay. She asked a good question here. In question 2, you don't have function.
Yeah.
So you will now take derivative.
Because they already give you MPK, right?
So what you're going to do is you're going to use the definition of MPK. What's the definition of MPK? When you increase the capital good by 1 more unit, what is your increase of the total product? Right?
That would
Okay.
be the price, right?
So look at the chart. Do you have the chart? Do you have the book?
No.
You guys don't have bring your books to the class?
I mean, Mine crashes all the time because I'm an electronic copy.
Page one.
Okay, page 1. Share with her maybe. She'll understand. Page 201.
No, I think we went over this when we first initially did this output chapter or whatever. I wrote down P times MPK equals PK, but I guess I forgot the V.
No, no. Actually, that formula is right. That formula is right, but P and PK, the name for it is V and PK. That's what book use.
Okay.
So the right hand side is still PK.
Yeah.
Okay. Okay. So for MPK, you have 3 columns there, right?
Mm-hmm.
When K changes from 0 to 1, what is the change of Q?
50.
That's it. 50 divided by 1.
Yep.
So MPK tells you when UK increase by 1 more unit, what is your increase of Q?
Okay.
So when K changes from 1 to 2, what is the change of Q? 100. So you 100 divided by another 1.
Alright, that makes a lot more sense.
Okay. Any other question on homework stuff? Everything else is very straightforward.
Yeah.
Is due this Saturday?
It is.
You should push it back.
Just get it done. Otherwise, it will be beginning of next week, so you're gonna get done in 1 week.
All the copies on homework and work, also